Friends, today we are going to see the MCQ based on the next part. There will be the MCQ based on the zero law of thermodynamics. The main aim of this law is if the two bodies, let's say the A and B, are in the thermal equilibrium independently, then same treatment is given to the other system C if there is a thermal equilibrium between the any two of that B and C, then it is written as A is equal to B and B is equal to C. From this equation you can conclude that A is in contact with the thermal equilibrium with the C. Now zeroth law of thermodynamics is having the MCQs. The MCQs will like that. The zeroth law of thermodynamics deals with thermal motion or say thermal equilibrium of the system. Okay. Then what is a work? It is nothing but is a fundamental physical property of the thermodynamics. Work. That work will nothing but done. It will done when an object is moved against an opposite force. Work is done when an object is moved against opposite force, applied pressure, like option will be there. Another MCQ on that particular work will be is the transfer of energy that makes use of organized motion, electrons or ions or atoms, molecules of the system. So work is the transfer of energy that makes use of organized motion, electron or ion or atoms or molecules of the system. Example: stretch spring, flow of current in the conductor, movement of the body, like this. Now, in generally, mechanical work is proportional to the applied force and the distance moved by the point of application in the direction of the force. Is proportional to the applied force and the distance moved by the point of application in the direction of the force. That is the mechanical work will be the answer. That you have to remember. That is a W is equal to F into W is directly proportional to the F into D. This formula you have to remember. If you see the mathematical derivation, you have to consider such a diagram. Here you can see this particular piston is there. If gas is going to expand, at that time you know pistons will go out. Same way, if you see the external pressure is applied, pistons with the area A is here. Okay, the distance between these two particular things will nothing but the L. Then work done by the gas can be calculated. A liquid expanding by the volume delta V against a constant external pressure P also calculated. If the piston has an area A moves through the distance D, the volume change is given by delta V is equal to A into L. If distance is L, then delta V is equal to A into L. We know force is equal to area into pressure. By the definition of the mechanical work, minus W is equal to force into distance. Therefore, minus W is equal to force is nothing but the P into A, distance is L, A into L is nothing but the delta V, minus W is equal to P delta V. This is the work, minus W is equal to P delta V, where delta V is equal to V2 minus V1. During the expansion, what will happen? V2 will be greater than V1. That's why delta V will be the positive and work will be the negative. That means work is done by the system on the surrounding. By the system on the surrounding. And if in the compression you know V1 will be greater than V2, or so V2 will be less than V1, that's why delta V will be the negative. and that's why work will be the positive, that will indicate work is done on the system by the surrounding. Okay, that you have to remember. Very simple it is. When work is negative, then then work is done dot by the system on the surrounding. Likewise option will be there. Okay, the MCQs will be there based on this particular work function. After integrating all this thing, now we have to talk about the total maximum work done during the isothermal. Isothermal means temperature is remains constant. Reversible process is given by minus W max is equal to integration delta dW. That is the minus W max is equal to P into delta V. We know ideal gas equation PV is equal to nRT, P is equal to nRT by V. On substituting this equation in this particular equation, you will get W minus W max is equal to integration starting from V1 to V2 nRT by V into dV. dV by V is nothing but the ln V. Okay, you can take the limit V2 V1, then ln V2 by V1. That equation you have to remember. W max is equal to 2.303 nRT log to the base 10 V2 minus V2 upon V1. There will be the, you have to calculate the work by using this particular formula also. MCQ may be there. See, like this numericals will be there. 1 mole of the gas occupying 3 dm cube is expanded against a constant pressure of 1 atmosphere to a volume of 15 dm cube. You have given the V1 and V2. External pressure is given. You have to calculate the W max. That may be for the MCQ purpose. Okay, you have to remember this formula. Minus W is equal to P external, or say PE into delta V. Here another sort of numerical is there. The 2 mole of an ideal gas is at 2 atmosphere and 27 degrees centigrade is compressed isothermally to that, so that of its volume. Compressed isothermally to half of its volume by external pressure 4 atmosphere. Calculate the work done. Number of moles is given, pressure is given, temperature is given, external pressure is given, and they asked you to calculate the W. Here R is given 0.082 atm per dm cube. That may be expressed in case of the atm per dm cube. You have to convert the temperature always in the Kelvin. First of all, PV is equal to nRT. They have provided the pressure simply. From that you can calculate the volume. Once you got the volume, then we can calculate the V2. That is the half of the original volume. Then delta V will be the negative, and you can take the formula W is equal to PEX into delta V. After putting all this thing, minus W is equal to, or say minus W is equal to PEX into delta V. After doing all this thing, 4 into 12.3, that is the 49.2. You have to convert it into joule. You have to multiply by this factor 101.32. It will, the answer will be this in the joule. The positive signs indicates that work is done on the system. Okay, by the surrounding. That we have already seen. Now we have to talk about the energy. Dot of the system is its capacity to do work. Dot is nothing but the capacity to do work. That is the energy. Energy of the system is nothing but the capacity to do work. Here MCQ may be like this. Dot of the system is its capacity to do work. option will be the energy, work, pressure, force, like this. And another MCQ will be like that, energy of the system is its dot 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 capacity to do work, capacity to walk, like that. State of system, it is defined by the temperature, pressure, volume and composition of its phases. Here the MCQ will be like that, dot 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 is defined by the temperature, pressure, volume and the composition of its phases. State of system is defined by dot 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 dot, like that the MCQ will be there. Then the internal energy we will see in the next lecture. Okay, these are the MCQs that will be based on this particular part. Remaining part we will see in the next lecture. Thank you.